Hello everyone. Okay, welcome back. I hope you have tried on this question to elicit the possible mode of heat transfer. Okay, the question is actually quite easy. Okay, it's actually what there's only one main mode of heat transfer that we're looking at, and that will be conduction. I'll run through the process of how I arrive at this particular answer. Okay, and I hope you guys also have the same way of doing it, or to be exact, you have your own system of doing it, of identifying the different modes of heat transfer. Based on the questions here, we are looking at is the copper pipe. Okay, so when we're talking about copper, okay, the particular things about copper here is, if we are talking about, is the medium. Okay, it is a metal, solid, it is metal. So if we are looking at this particular medium, the possible or the related mode of heat transfer we are looking at for this will actually be conduction. Okay, some of us, we might argue that copper, when we talk about copper, will it be that the copper is actually shiny surfaces, or is it dull surfaces? So from this question, from the word copper pipe, it's quite difficult to infer that the copper pipe here refer to a shiny surface, or is it a dull surface. So that's why for this particular question here, the clues that I sieve out from the word copper pipe is only the medium, not the texture, not the color, not the surfaces. Okay, because it has too little clue to actually tell us otherwise. Okay, so we use, for copper, we will stick to conduction, mainly because of the medium that's given. Okay, because it is the medium. Now here we look at the hot water being coming in from the pipe. Okay, and after that you have cooled water going out. Okay, so in the process of the water coming in from point A and the water leaving out from the point B, you'll find that the temperature of the water actually decreases. So when hot water enters the pipe, here we will know that hot water actually enters the pipe, so which means the pipe at A is actually hot. Okay, so it's actually high temperature. Okay, so which means at A is actually high temperature. So which means that at A, when the hot water enters the pipe, the hot water temperature is actually higher than the environment temperature. Okay, so which means the water in the pipe is actually higher than the environment, and because of that, I will know that the heat transfer, the direction of heat transfer will be actually from the pipe to the surrounding. Okay, this is how I actually decide on the direction of heat transfer. Okay, whether it's from the surfaces to the environment, or the environment to the surfaces. I look at one thing, the temperature difference between these two particular modes. So once I decided on that, the heat will be transferred from the pipe to the surrounding, and I know the method of heat transfer will be through conduction. Okay, I will then actually evoke the necessary keywords for conductions, which is given in the 8.2 videos. Then after that, I will just plug and paste, or plug and play the keywords into the question, and I will actually get a more or less correct answer for the question itself. So here I will be looking at the copper pipe, okay, and the heat will be conducted from the pipe to the surrounding. Okay, so this is what we mean. This is how I actually decide on the fact that the possible modes that I'm looking for is actually conductions. Okay, the other mode of heat transfer that I can actually infer out is actually by radiations, because what we have is that the temperature of the substances is actually high. Okay, the pipe temperature is high, so you actually have a high temperature at the pipe. So from here, you look at the surface temperature, which is the factor number 4 for radiation. So if I will know that the object is actually high temperature. Okay, so at high temperature, I will be able to radiate my energy out, or radiate my thermal energy out from the pipe to the surrounding. So I will be actually acting as a radiator. Okay, if we are looking at temperature here. Okay, but from the question, I will know that versus radiation as the mode versus conduction, which of the process is the main mode of heat transfer, I will choose conduction, because the pipe itself that is given is actually from point A to point B. I have a whole tube that is made of copper. But if you look at the temperature of the water, I'm only looking at point A, and the most is like half of the pipe is hot. Then after that, the other half of the pipe is actually proceed on to being cooled by the cold, clean water. So if you talk about the area of exposure, the area of high temperature area, I would say that the high temperature area, hot temperature area, the high temperature area that is acting as radiation is actually not as significant as the conduction, as the pipe, the whole pipe that is copper. Okay, so that's why I would say that between conduction and radiation, I actually decided on that. Based on the clue and based on the factors, I actually decided on that copper is conduction is the main mode of heat transfer in this question here. Okay, and this is how I actually work through my thinking, work through my clues to actually decide on the possible answer for the question itself. Okay, work on the clues, work on the questions. Okay, and this is one of the things that I actually encourage the students to do. Okay, to practice when they have a tutorial assignment, when they have homework, run through the question first. Don't focus on solving the question. Focus on the system that you have or you can set up to actually analyze the question first. Okay, to analyze the question and to decide and eventually end with the possible modes of heat transfer. Okay, it's the system that you are interested in setting up. Okay, that is what you should aim to achieve. We have another classic example here. We have here, which is vacuum flask. Usually for vacuum flask question, you'll find that the questions parts are actually well labeled. Okay, and these well labeled parts are actually clues to the students to talk about different parts of different modes of heat transfer. For example, if the question is talking about plastic stopper, okay, the fact that it mentioned plastic means the possible mode of heat transfer I'm looking at will be conduction. Okay, so if I'm looking at stopper as a whole, okay, stopper means it is, I would say it has the same function as a lid to prevent the hot air from rising up. Okay, if it's hot water inside, okay, because it's hot water inside, to prevent the hot water or the hot air from rising up, which is the trap air. Okay, so the stopper here, the main function it does is actually to reduce convection. Okay, you look at how I decipher from the labelings, how I analyze the labelings and decipher the possible modes of heat transfer. If looking at trap air, okay, the trap air here, of course the trap air here, it could mean two things. Like I mentioned before, it could mean convection, whereby hot rise, cold sink. Okay, so this will be what I call convection. On the other hand, I also can infer that the fact that air is given to me, so air is actually acting as a insulator. So I will take it that conduction could be involved here if I'm talking about the trap air. So whether the trap air serve as a convection mode or serve as a conduction mode, it really depends on the question and how you analyze the question. But as for now, the labeling trap air, plastic stopper, it does open certain doors. It does open the doors to conductions and open the doors for convection. So that's where students, you have actually to need to write down or to jot down what are the possible doors or what are the possible answers that you are looking at, the permutation of answers. Okay, if you are looking at vacuum, okay, if you are looking for vacuum, it's important to say that vacuum, okay, conduct and convection is stopped completely, because conduct and convection needs a medium. So convection, the main purpose of we having vacuum inside a vacuum flask primarily is actually to stop these two methods. Is to stop conduction and convection. And that's the one of the purpose that I labeled it as vacuum, especially to let students know that, hey, take note, convection and conduction is stopped here through the use of vacuum. Okay, then so when I talk about silver surface, okay, silver surface here it could mean radiations, because silver is actually on the color of the material. It could be also means the texture, because silver is actually shiny. It could be shiny. Okay, but no matter whether it's shiny or not, we will not know. But I do know that silver is a color, and color, it belongs to one of the factors in radiations. Okay, the other one we took is glass. Okay, double wall glass, it could be the glass referring to the material itself. Okay, if I'm looking at material, I'm looking at conduction itself as a more heat transfer. Okay, if I'm looking at glass itself, whether it's transparent or not, well, my mistake, it will not be transparent because the question says silver. Okay, so it will silver surface. So glass, primarily the main purpose of me labeling glass is to tell the students about the material. So the possible mode that I'm looking at is actually conductions. Outer case, okay, we will not know the outer case because it has little information. It could be plastic, it could be metal. Okay, so outer case actually depends on the question itself. Okay, so you need more information, okay, for outer case. But I do know cork here, it refers to the material, and this material is like air. As science students, we should know that air, cork, all these are bad conductors. They are actually good insulators that we use, okay, to reduce the heat conducted from the surfaces or from any surfaces. So here we are looking at is actually conduction. Okay, so by looking at the material that we are looking for, looking at the labeling that the question gave, you'll find that we are actually able to infer different modes of heat transfer at different labelings or at different locations. Sometimes the same label actually prompt us two modes of heat transfer. For example, conduction and convection, just by using plastic stopper. So it depends on how you want to craft your answer to tackle the questions that is given, the context of the question. Okay, so same thing, trap air. Okay, it could mean convections. Okay, if you focus on the word trap, okay, if you focus on the word air, you'll find that air is actually a bad conductor. Okay, so you could be talking about the mode of transfer will be on conductions. So it really depends on what you are looking at. But end of the day, is your analysis. Okay, so you have to analyze the questions before you actually read the questions to actually tackle the question itself. Okay, so that's why I always emphasize the first main thing about conduct, convect, radiation, this topic is actually the student's analysis of the questions. Okay, it's not about the keywords, it's not about what you can write, because all these keywords I can actually give you. Okay, or your teachers can actually craft it out for you. You have a structure. But with a good structure, if the students cannot successfully identify the correct modes of heat transfer, that structure will be useless. Okay, so if you look at the priority is not about the structure, it's about your abilities to actually analyze the questions to choose the correct modes. Okay, so that's why the analysis is utmost important, okay, for these questions. Okay, and similarly we have other questions that's in the textbook and the workbook. You can run through with them, okay, to test out your system of analyzing, okay, your own system of analyzing, such that you will actually arrive at the correct mode of heat transfer. Okay, so with this, okay, I will wrap up this with the same slides or the same clues that I given in the beginning. Okay, the importance of the relevant clues that we are looking for in the questions. Take note, I emphasize again, the list that I came up with here are not comprehensive. It's up to my knowledge, it's not comprehensive. If you have new additions, do let me know. Okay, just leave your additional clues or things that I miss out in the comments column below. Okay, so I hope these clues are actually a good starting point, or maybe a good guiding questions for you to set up your own analysis system. Okay, so all the best, okay, to everybody for this topic. Okay, and see you soon.